This is Unit 8, Lesson 9, and in this lesson we are going to be solving rational equations. We've done a lot of rational stuff, simplifying, multiplying, graphing rational functions, and now we're going to be solving rational equations. So what it means to be a rational equation is an equation that has rational expressions in it or fractions in it. So if you see numerators and denominators within an equation, which means there's an equal sign, that's how you know it's a rational equation. So we have two different methods, and I'm going to talk to you about when it would make the most sense to use your different methods, and we are going to do the odds on these next two pages. So starting with number one. Method number one, we solve by using proportions. So proportions, the first step says to condense into a proportion. So I would really recommend using this method only if you already have proportions. And proportions mean you have just one expression on the left, one expression on the right, and that's it. There's no addition or subtraction of separate expressions. So just to give you an idea of what I mean, I want to show you the second page. So this is not a proportion because it's one expression minus another expression. So we wouldn't use method one if it looked something like number 7. But number 1, we can use method 1 here. We cross multiply to solve. So cross multiplying means we take this numerator and multiply it by this denominator, and then we set it equal to this numerator multiplied by this denominator. So that's what we're going to do. So this numerator times this denominator, so 7 times x, set it equal to this numerator times this denominator, so 4 times x minus 6. And if it's a whole expression, you want to be super careful about putting it in parentheses. So what you're actually doing when you're cross multiplying is first you're multiplying each side by this denominator, so it cancels from the lefts, and then it multiplies over to the right, like this. Then you're multiplying both sides by this denominator, which makes it cancel from the right, and it multiplies over onto the left, like this. So that's what you're technically doing when we cross multiply. And then you solve. So this left-hand side is just a 7x. The right-hand side, I am going to distribute. So I get this, and then I can solve. So solving means I'm going to subtract 4x from both sides. 7x minus 4x leaves me with 3x, and this is still a negative 24. Don't forget to keep that sign. And then divide both sides by 3. So divide the left-hand side by 3, and on the right, negative 24 divided by 3 is negative 8. So we check all solutions. Here's where you could have an extraneous solution, is when you end up with 0 in the denominator. Because if we have denominators, we have a restricted domain. So this, if I try to sub in negative 8, this denominator would be negative 8 minus 6, which is negative 14, which is fine. As long as it's not 0, your answer is fine. And then here, plug negative 8 into this denominator, and it's negative 8, which is fine. So that means that x equals negative 8 is our answer for number 1. All right, let's do number 3. So this one, it's method number 1 because it's set up like a proportion, just one expression on the left, one expression on the right. So we solve by cross multiplying. So this numerator times this denominator, so r times r would be r squared, equals, and then this numerator times this denominator, so the 4 is going to get distributed to the r minus 1. So let's simplify. We have r squared equals, and then distribute this 4, looks like that. Now this is a quadratic, r squared. Anytime you see an x squared, an r squared, an a squared, it means it's a quadratic. You're going to want to at least attempt to solve it by factoring, which means putting everything on one side of the equation. All right, so subtract these pieces over. We will have r squared minus 4r, and then plus 4. We get everything on one side, and the other side should be equal to 0, and then you solve by factoring. So since r squared is just an r squared, we don't have to worry about a GCF, we don't have to worry about slide and divide, we just set up r times r. What we're looking for here are two numbers that multiply to a positive 4 and add to a negative 4. So that would be a minus 2 and a minus 2. So it's actually just a repeat of the same factor. So now set each of these equal to 0, and we can solve. So take r minus 2 and set that equal to 0, and I get 2. And then this is just a repeat factor. Set r minus 2 equal to 0, and I get a repeat. So double check, plugging back in r minus 1 would be 2 minus 1, which is not 0, so that's fine. Plugging it in here would just be 2, which is not 0, so that's fine. So this is just a repeat answer, so I'm just going to write it once over here, box it up. You don't have to write it twice if it's the very same thing. All right, let's do the last one on this page, number 5. This is the last one that's set up like a proportion. So this is the last time we're going to use method 1. So one expression here, one expression here. We're going to solve by cross multiplying. So this numerator times this denominator, so y gets multiplied times y plus 5, equals this numerator times this denominator, so the y plus 8 gets multiplied by 3. So even though the 3 is on the right, you still distribute it to both of these pieces. So let's set that up. So distribute this y to the parentheses. You will get y squared plus 5y equals, and then distribute this 3 to the parentheses. So 3y plus 24. Now, just like number 3, you see a quadratic here, which means you're going to factor, which means I need to move everything over to one side of the equation. So keep the y squared here. Subtract the 3y from both sides, so 5y minus 3y would be 2y, and then subtract the 24. So I get everything on one side of my equation, and then I can work on factoring. So it's just a y squared, which means I don't need to do anything fancy. It's just going to be y times y. And for my numbers that are missing here, they need to multiply to a negative 24. They need to add up to a positive 2. So that would be positive 6 and negative 4. So just like number 3, set each of these equal to 0. We set y plus 6 equal to 0, and we solve by subtracting 6. And then we set y minus 4 equal to 0, and we solve by adding 4. So those are our 2 answers. Let's check them. This is not a variable, so we don't need to worry about it. We need to check the y in here. So if I sub in negative 6 plus 5 is not 0. And check the 4, 4 plus 5 is also not 0. So I get 2 different answers for number 5, which is definitely possible. All right, so let's look on the next page. I'm going to keep this method number 2 using an LCD. So you multiply each side of the equation by the least common denominator. Okay, so multiply each side of the equation by the least common denominator. If we need to keep flipping back to that, we can. So we're going to keep doing the odds. So number 7, we look at these denominators. We've got 3, n, and 6. So our goal with this method is to make the denominators cancel. And in order to make the denominators cancel, you need to multiply by something that's a multiple of 3, and it's a multiple of n, and it's a multiple of 6. But the trick with it being the least common multiple is you want it to be as small as it possibly can be. So you want something that's going to make the 3 cancel, and make the n cancel, and make the 6 cancel. And here's our answer. Our LCD here is a 6n. If I multiply here, the 3 will cancel, and the n will cancel, and the 6 will cancel. So you want it to be the smallest possible thing. So the least common multiple of 6 and 3 is 6, and then it also needs an n. All right, so what we do with this method is we multiply everything on both sides by a 6n. Okay, so we take both sides of this equation, multiply everything by a 6n. So that 6n gets distributed. So I'm going to write it out like that. So the 6n gets distributed to the 4 over 3 minus, and the 6n gets distributed to the 7 over n, equals, and the 6n gets distributed to the 1 over 6. So you can see these denominators should all end up canceling. So 6 over 3 reduces down to 2 right here. You see that 3 cancels, which is what we were going for. Then the n over n just completely cancels, which is good. So now 2 of our denominators are gone. And then this one, the 6 over 6 cancels, and that third denominator is gone. So if all your denominators don't cancel, then you pick the wrong LCD. You might need to pick something bigger so that everything cancels out. So now we multiply what's left and we can solve. So here 2 times n times 4, 2 times n times 4 would be an 8n, minus, and then here we have 6 times 7, which is 42, equals n times 1, which is just an n. So here we're going to solve for n. It turns into a much simpler equation. I'll subtract this 8n from both sides, so it cancels from the left. And on the right, when I do n minus 8n, I get a negative 7n. And then to get the n by itself, divide both sides by negative 7. So divide negative 42 by negative 7, and I get 6. And divide by negative 7 here, and it cancels. So check this 6 out. Here's the only place where a variable goes. If I plug a 6 in here, the denominator is just 6, which is fine, as long as it's not 0. So that's our answer for number 7. All right, 2 more. Let's look at these denominators. This denominator is a p minus 2, so that means that my LCD has to have a factor of p minus 2, so that denominator will cancel. This one doesn't have a denominator, so we don't have to worry about anything canceling here. And this denominator is a p squared minus 4, which we're going to factor. Okay, so the p squared minus 4 is the difference of squares, so we can factor it to p minus 2, p plus 2. So my LCD needs a p minus 2 and it needs a p plus 2 so that both of those things can cancel. All right, so I'm going to take both sides of this equation. I'm going to multiply everything by a p minus 2 so that this will cancel. And that will actually also make this cancel. And then to make sure this cancels, I need to multiply everything by a p plus 2. So just kind of look denominator by denominator and make sure that you're multiplying in something that will make everything cancel. Okay, so just like number 7, I'm going to distribute. So I distribute a p minus 2, p plus 2 to my first expression, which is p over a p minus 2, plus, and then distribute it to this next one. Gets multiplied by that 2, equals, and then distribute here. We're just going to bleed over into number 10 because we're not doing it, so it's fine. Times 8 over, and I'm going to write the factored version. So if we did this step correctly, all of our denominators should cancel. So remember, with binomials, we can only eliminate them if they're perfect matches, right? So p minus 2, nothing to cancel here. And then p minus 2 over p minus 2, p plus 2 over p plus 2. So all my denominators canceled out, and now I just worry about solving this equation. So here I have p plus 2 times p. So distribute that p, and I will get p squared plus 2p plus, and then this I know is the difference of squares pattern. So when I multiply this out, I know I get p squared minus 4, and then I have a 2 that I need to multiply by. So distribute that 2, and I get 2p squared minus 8. That's my left-hand side. Equals, and then on the right, everything canceled except for this little 8. Okay, so I see quadratics, which means I'm going to solve by factoring. So let's get everything on one side. So p squared, 2p squared, that's 3p squared. 2p and then nothing else, so that's just a 2p. And then subtract my 8 over to the left. So negative 8 minus 8 would be a negative 16. So now everything's on one side of the equation. So this is a 3 that does not divide out, so that means I have to do slide and divide. So slide and divide means I'm going to multiply the 3 over to the end, and I get a negative 48. And then I can factor this version of it. So p squared would be p times p. And for my numbers, I need to multiply to a negative 48 and add to a positive 2. So that would be a positive 8 and a negative 6. So make sure we're not solving this. Make sure you finish off the slide and divide by taking the 3 and dividing these both out. All right, so let me finish it over here. So this 8 over 3 does not reduce, which means the 3 slides back to the front, like that. The 6 over 3 does reduce. It reduces down to 2. So that is what that second factor looks like. Okay, so let's set these equal to 0. This one, if I set it equal to 0, I subtract 8 and then divide by 3. So I get negative 8 thirds. If you want to turn that into a mixed fraction, you can. This one, if I set p minus 2 equal to 0, I get 2. So I'm going to check my answers. If I plug negative 8 thirds in here, negative 8 thirds minus 2, you don't have to know what it is, but you know it's not 0. And then same thing here. If you square it and then subtract 4, you don't get 4 when you square it, which means you're not going to get 0 when you subtract it. So this answer is fine. Plug in the 2. 2 minus 2 is 0. So this is my first extraneous solution. So if it gives you a denominator of 0, you just cross it out. You don't count it. All right, so just one answer for number 9. Last problem here, number 11. We look for the LCD. This denominator is an x plus 3. This doesn't have one. And this denominator is an x plus 3. So that one's actually pretty straightforward. The LCD is just that one denominator of x plus 3. So I'm going to distribute it like this. So just writing it 3 times right here. So this first denominator, the x plus 3 cancels. This one I end up multiplying, and this one, the x plus 3 cancels. So let's write what we have left. On the left-hand side, we just have an x plus 6 equals, and then right here, the 2 multiplies to the x plus 3, so that distributes. And then minus, be careful with this subtraction. The subtraction will distribute, so we'll subtract the 5x, and we'll subtract the 12. Be careful with that sign. All right, so now let's solve. So x plus 6, nothing to simplify on that left-hand side. On the right, the x's combine up to a negative 3x, and the constants combine up to a negative 6. So now let's solve. I will add this 3x to both sides, so x plus 3x is 4x. And then I'll subtract this 6 from both sides. So negative 6 minus 6 is a negative 12. Finally, divide both sides by 4. So on the right, negative 12 divided by 4 is a negative 3. So check that answer out. If I try to plug it in here, I get negative 3 plus 3, which is 0. So that means that this is an extraneous solution, and that was the only one I had, unlike number 9. So that means that I have no solution for number 11.